Now, dynamics is study of force and motion together. We will be studying, like in kinematics, we study motion, but we do not study the source of motion or what is producing acceleration. We just only solve questions involving acceleration. But if we start focusing on what is producing that acceleration, the force comes in, and study of force and motion together is known as dynamics. Now, what is force? Force is an agency that tends to produce or produces change. Force is push or pull of one object on another. So for a system of force to work, there has to be an object that exerts force, an object that force is exerted on, and a force that completes the system of forces. Now, force is a push or pull of one object on another object. Now, Newton's first law of motion. If there is no unbalanced force, an object at rest will remain at rest, and a moving object will keep moving with uniform speed in a straight line. Now, this tells you a lot about the behavior of force, that why do we need force? Force is not needed to make an object move or keep an object moving. It is only needed to change the state of an object. So we can increase or decrease, or we can change overall the speed of an object. Plus, we can change direction of motion of an object. Just 1 second. So force is required to produce the change, because without force, there will be no change. And this property is also known as inertia. This is why this law is also known as law of this law is also known as law of inertia. What is inertia? Inertia is resistance to change in motion. Like if an object is moving, it wants to keep moving. And if it is at rest, it wants to stay at rest. Whatever an object is doing, it wants to stay in the same condition. And this behavior is known as inertia, and force is required to overcome that inertia, overcome that resistance to change, produce change. And this resistance to change Inertia is also known as mass. Mass of an object is a measure of its inertia. When we say an object is massive, it means it has a lot of inertia. It will be very difficult to move it if it is at rest, and if it will be very difficult to stop it if it is already moving. So mass means more inertia or more difficult to produce change. Now, Newton's second law of motion. Net force on an object is directly proportional to rate of change of momentum. You might not know the meaning of momentum right now because we haven't studied it in this course, but it is coming up in the next chapter, next subtopic actually. Net force on an object is directly proportional to rate of change of momentum, or net force is directly proportional to acceleration if mass is constant. So F is directly proportional to A, then F equals to ma, where F is not an ordinary force. F is net force in newtons. M is mass in kilograms, and remember, mass must be in kilograms. It is not a choice, it is a compulsion. And A is acceleration in meter per second square. So this is Newton's second law, Newton's third law. For every action, there is an equal but opposite reaction. If object A exerts force on object B, then object B exerts an equal but opposite force on object A. This is the same thing said in many different words. So both of them are considered as statements of Newton's third law. If A exerts force on B, then B exerts an equal and opposite force on A. Or we can say for every action there is an equal but opposite reaction. No. Applied, resistive, and net force. What is meant by applied force? Force exerted by an external source. Also known as total force or gross force. So applied force is the total force that any external source is applying. Resistive force or forces that oppose motion are called resistive forces. Some common resistive forces are: number one, drag force or air resistance. Number two, friction. So these are the forces that always oppose motion. What does the friction do? It opposes motion. What do you think drag force does? It opposes motion. And air resistance is a drag force of air. Now, net force. Also known as resultant force, unbalanced force, Okay, net force can sometimes named as unbalanced force or resultant force. I started like there are too many other names, but these are two that are coming to my head right now. Now, net force equals to applied force minus resistive force. Now, this is an object M with mass M. The forward force is F. The resistive force is Fr. Applied force is F. Total resistive force is Fr. So net force will be F minus Fr. But on the previous page, we did net force equal to something else. Right? Net force equals to mass times acceleration. So F minus Fr, like applied force minus resistive force, equals to mass times acceleration. So if you're looking for net force, you can either do it by applied force minus resistive force, or you can do it by multiplying mass and acceleration. Mass times acceleration is not any ordinary force, it is net force, right? To keep it in mind. If you're looking for force, do not immediately think that MA is going to be a final answer. It is only the net force. If you're looking for net force, yes, that is it. But if you're looking for applied force, something else, then you have to be more careful. Now, this is an object. There is a forward force. There is a backward force. Let's say this is question. So the forward force is 200 newtons. The backward force is 60 newtons. Mass of the object is 250 kg. This is resistive force. This is applied force. Number one, calculate net force. Number two, calculate acceleration. Let's see if these are the two things we have to calculate. Do you think any one of you can do it?
I think
So for finding a net force, what we can do is we can just simply subtract the backward force from the forward force. So 200 minus 60 is 140. And as we know, net force equals to mass times acceleration. We can make acceleration subject to formula in that formula. A becomes equal to F over M. F is 140, M is 250. And be careful when we are using A equals to F over M or F equals to MA, we have to be 100% sure that the force that we are putting in is the net force. Okay, so it's not the total force, it is the net force acting on the object. Now, what are the different names that force can come up with in your syllabus?
Sir, can you say that again? What did you say?
What are different types of force?
Gravitational force?
Yes. Let's put it number one. Gravitational force, or also known as
What?
weight. Okay. And applied force. Resistive force. Okay, resistive force and applied force, and then it can be tension. Tension means force exerted by rope acting on both ends. No. Tension, friction, applied force, gravitational force, and there is another force known as upthrust. I'm trying to stay within IGCSE and O-level syllabus. So these are the forces that you can deal with, and examiner can ask you to explain one of them, what is meant by any one of them. These kind of questions, they normally appear. Gravitational force or weight. Weight equals to mg, where W is weight, m is mass in kilogram, and G is gravitational field strength for Earth. G equals to 10 newtons for each kg. That means that weight of 1 kg will be 10 Newton on Earth. So if you have 2 kgs, the weight will be 20 Newton, 3 kgs, 30 Newton. But remember, in this case, mass has to be in kgs. Now, net force equals to F. F equals to. So these are the different kinds of forces that you might see in this topic. Now, okay, I'm thinking about a question. Well, before we go into the question, let's discuss the factors that affect air resistance. First of all, what is drag force? When a solid moves through a fluid, what is meant by fluid? Fluid means liquid or gas. Whenever a solid moves through a fluid, the solid displaces the molecules of fluid on its way. So if molecules are coming in the way of a solid moving in a fluid, solid has to push those molecules away. Now, in Newton's third law, we just discussed that when object A exerts force on object B, then object B is supposed to exert an equal but opposite force on object A. So if a solid is exerting force on a molecule, then molecule is supposed to exert a force back on solid. Now, you would say that molecule is very small. That how come air resistance becomes so significant? And there will be very small force required to move the molecule. So molecule will be exerting very small force back on object. And you are perfectly right. It will be a very, very small force that a single molecule exerts. But what happens if you multiply a very small number with a very large number? Although there is a very small force required to move one single molecule, but there are so many molecules. So what happens when that small number multiplies a significantly very large number? Answer is you get a reasonable quantity of something. So that is why there is a drag force whenever a solid moves in a fluid. Okay, now move on. Question is factors. Factors that affect the size of drag force. Number one, area of front of moving object. Area of the front of moving object means that the face of the object has to have a smaller area. If it would have larger area, there will be more air resistance. And it is not the surface area of the object. When somebody says how area affects the drag force, you would say area of the front affects the drag force, not the total area of the object. area front of object, and excuse me, this is why the front of modern cars are made very sleeky and very small. They're not making a smaller car because cars are still big or getting bigger, but the problem is to make them fuel efficient and make them uh, so what should I say, streamlined design that they can make their way through air easily. What we do is we make their front uh, very small and very edgy, so it can easily make its way through the air. So area of the front of an object. Number two, speed of moving object. And the last is density and viscosity of the fluid. Okay. We'll resume from the same point tomorrow. Till then, take care. Allah Hafiz.
Thank you, sir.